Okay, this last section is really getting into probability, looking at what are called simple and compound events. When we look at number 1, it says in a regular deck of cards, what's the probability of drawing an ace? This is just a simple event. We are just focusing on one specific probability. We know how probabilities work. We are looking at the number of aces versus number of cards in deck. So let's go ahead and look at that. We have, how many aces do we have? We have 4. Regular deck of cards has 52. So probability of drawing an ace is 1 in 13. Okay, pretty simple type of probability. Now we're going to start looking at something called a compound, because what is the probability of drawing an ace and then a king? So this is a compound event. There's 2 different ways that we can do this. We can do without replacing that card again, and then with replacing that card. So we're going to look at 2 different types of probabilities. If we are looking at a compound event with that word and, we are going to multiply the probabilities. And spell right. Probabilities. Goodness, I'm sorry here. Okay, so let's look at without replacing. What's the probability of drawing an ace? Remember, 4 out of 52. And then a king. So without replacing that ace, how many kings do we have in there? We have 4. How many cards do we have? 51. So this is what's called a dependent event, because the outcome of that second is dependent on what happens on that first one, because we got a card taken away. Okay, so multiplying those 2 together, we end up with 4 over 663. Okay, so again, that is dependent because we are not replacing that. If we are replacing, let's go ahead and look at what happens. Probability of drawing an ace is 4 out of 52. And then probability of drawing that king. If we replace that ace, it's a 4 out of, again, a 52 chance because we have that card back. So that gives us a 1 in 169 chance to draw an ace and then a king. Okay, so 2 kind of different type of probabilities, looking at dependent and independent. Now let's look at 3. This is saying what's the probability of drawing an ace or a king. Okay, not quite so hard on the stipulations here, so when we see that word or, we're just going to add our probabilities. And I'm not going to talk so I can write this right. Okay, so let's go ahead and look at this. Probabilities of drawing an ace, 4 out of 52, or we're going to draw a king. So, and 4 out of 52. Okay, so probability is a 2 out of 13. This is called mutually exclusive because that or says it doesn't really matter what's happening here. We're just going to combine those 2 together. So again, one that we're going to look at in this section. Now let's look at 4. What is the probability of drawing an ace or a diamond? So let's go ahead and look at each of these pieces separately. And actually, I'm going to change these colors. What am I going to use? I'm going to use red. I'm going to use blue. And I'll tell you why in just a minute. So what's the probabilities of drawing an ace? Remember that we have that word or. So we understand or means that we're going to add aces. We've gotten pretty good at knowing that there's 4 out of 52 in a deck. How about diamonds? How many diamonds are there? Well, there's 13 of each suit, so we're going to add 13 of those 52. But guess what? One of those aces is a diamond. So what we're going to have to do in purple, I'm going to have to subtract that probability that one of those 52 is actually that ace of diamonds. Okay. Okay, this is called not mutually exclusive because, again, they're not independent of each other. They actually have something in common. So we do have to look at the probabilities of each and then subtract the one that occurs with both of them. So there is a 4 in 13 chance that we could draw an ace or a diamond. Okay, a lot of different types of vocab here. Students are, for the most part, pretty good at probabilities, understanding them. It's just sometimes understanding what that vocab means as well. So if they see that vocab, they know what they're supposed to do with that problem. So go ahead and get out the notes and vocab for this section. Okay, objective of this section is to determine the probability of those simple and compound events. So understanding that we're going to focus on a lot of compound events that have little simple events connected to them. So understanding that's what compound events is 2 or more simple events. The one that we started with was that independent event, remembering that the outcome of one does not affect the outcome of the other. And so when we see that probability of both, we are multiplying them because it's a probability of one and the other. So let's look at example 1. It says the bag contains 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is selected, replaced, and a second marble is selected. Find the probability of selecting a black marble, then a yellow marble. Okay, a lot of times when we look at probabilities, the way that they write this is P, the probability of a black, and then a yellow. So what we're going to do is find the probability of that black. Since they said and, we are going to multiply that by the probability of a yellow. Okay, adding these all up, there's 21 total marbles. So we know that that's our total outcome. How many black marbles do we have? We have 6. So the probability of drawing a black marble is 6 out of 21. They have a nice clue word there. That marble is then replaced. So what's the probability of then drawing a yellow? There's 4 of them. Out of how many marbles? 21 again, because again they replaced that. So this is called an independent event because that yellow marble is not dependent on that black. Okay, this simplifies down to 8 over 147, or if we did want to look at that, 8 divided by 147 is about 5.4%. So you might see the answer as a fraction, you might see it as a percent as well. Okay, so again, probabilities, look at those words, look at those clue words. Remember, it's the outcome you're looking at versus the total outcome. Go ahead and try guided practice 1. Okay, there we go. Blue is 9 out of 21. Green is 2 out of 21, which gives us about a 4% chance. B is a little bit different because not black. There's 15 of the 21 that are not black. 9 out of 21 that are blue. So that does give us about a 30.6%. So again, because that was replaced, those are considered independent events. Now we're looking at dependent, when the outcome of one event does affect the outcome of another event. They give some good examples here, but we looked at that dependent event about drawing that ace of diamonds, which did kind of mess up, not really mess up our probabilities, but it did change them. So let's go ahead and look at example 2. Cynthia randomly draws 3 cards from a standard deck, one at a time, without replacement. There's why this is considered a dependent event. So we're supposed to find the probability that the cards are drawn in the given order. So we are going to draw a diamond, and then a spade, and then another diamond. So let's go for this. Diamond. Probability of drawing a diamond is 13 out of 52 because there's 13 diamonds. Probability of drawing a spade. There are 13 spades, but since we did not replace that card, we now have 51 cards. Now we're going to draw another diamond. Well, we already used up one of the diamonds. So how many do we have left? We have 12. How many total cards in our deck do we have left? We have 50. So looking at that dependent event, we are slowly losing cards. We are also slowly losing diamonds. Okay, multiplying those together, we get 13 over 850, which does give us about a 1.5%. Okay, so let's look at another one of these. We have a probability of drawing a 4. then another 4, and then something that's not a jack. Okay, so let's look at this. How many 4s do we have? We have 4 out of 52. If we don't replace that 4, we have 3 more 4s, and now we only have 51 cards. Not a jack. How many jacks do we have? We have 4. Okay, we already got rid of a 4 and a 4, so we actually have 4 that are not jacks. Okay, I'm sorry. Okay, out of the 50 that we have left, 4 of those are jacks. So that means that we have 46 out of those 50 that actually will work. Okay, so again, here's our 4s. Got rid of a 4, got rid of 2 cards, and 46 of those are not jacks. Probabilities on this are pretty crazy. We're at about 23 over 5,525, or that's about a 0.4% that this is going to happen. Okay, so dependent events is going to happen without that replacement. All right, go ahead and try guided practice 2. Okay, and there we go. Again, these are dependent events because we did not replace that, which means that each of the probabilities after the first do depend on that happens before. Okay, let's go ahead and now look at that mutually exclusive. The events that cannot occur at the same time are called mutually exclusive. So again, that's when we see the word or. That's when we're going to start adding in here. Okay, so our probabilities now are just going to be adding. It said a die is being rolled. We're supposed to find each probability. Find the probability of rolling a 3 or a 5. Well, how many numbers are on a die? We know that there are 6, so the outcome is 6. There is 1 3. Okay, or the probability of a 5, which is 1 out of 6. Okay, this simplifies down to 2/6, or we could say 1/3. If we wanted to look at that, we could say or even 33%. Okay, here's another mutually exclusive, at least a 4. So what's the probability of rolling at least a 4? Well, at least that could be a 4, it could be a 5, or it could be a 6. So there are 3 outcomes out of the 6 possible. Probability of drawing at or rolling at least a 4 is 1/2 or 50%. So understand that's also mutually exclusive. Events that can't happen at the same time is drawing a 4, a 5, and a 6 at the same time. Okay, some new vocab, new concepts. Go ahead and try guided practice 3. Okay, and there we go. Less than 3, not equal to. So it's just a 2 and a 1, which gives us a 1/3 probability or 33%. Evens, 2, 4, and 6. So that's another 50%er. Again, mutually exclusive, 2 things that cannot happen at the same time. Remember what we talked about with probabilities that are not mutually exclusive. They did a good job in this Venn diagram to explain that if we look at 2s and diamonds, there is that one probability of a 2 of diamonds that we have to subtract. So we have to get rid of that one probability, like we did with our ace of diamonds. Okay, so we look at the 2 probabilities, we subtract the one that coincides together. So let's look at their real world example. It says of 240 girls, 176 are on the honor roll, 48 play sports, and 36 are on the honor roll and play sports. What's the probability that a randomly selected student plays sports or is on the honor roll? Okay, they do say the word or in here, so that means that we have to look at the probability of sports, that they're in sports. We're going to add that to the probability that they're on the honor roll, but it doesn't say and together, so we're going to have to subtract those that are sports and honor roll. Okay, Adding up the total amount of girls, again, they say that there's 240. So those that play sports, we have a 48 out of 240 chance that they play sports. Plus those that are on the honor roll, there's 176 out of the 240 that are on the honor roll. But again, we have to get rid of that probability of sports and honor roll together. So that 36 out of 240, we need to subtract. Okay, that does simplify down to 47 out of 60 using your handy dandy calculator, okay, which is about a 78% chance that a student plays sports or is on the honor roll. Okay, again, this is not mutually exclusive because we did have to subtract that overlap. Okay, with that in mind, go ahead and try guided practice 4. Okay, writing the probabilities out as words and then filling in the blanks later with actual numbers does help, especially in situations like this when we're dealing with a lot of numbers and a lot of statistics. Okay, remember this is a not mutually exclusive because we do have to get rid of that overlap. Okay, again, a lot of vocab, but really writing this out and understanding what it is that you need to know will help. So go ahead and try the assignment for this section.